This lesson is on solving inequalities. An inequality is basically two expressions related with an inequality symbol. Those symbols are less than, greater than, less than or equal to, greater than or equal to, or not equal to. If you are having troubles remembering whether the symbol is less than or greater than, just remember that the two-pronged component of the symbol relates to the bigger component and the single-pronged is the smaller. You could also think of an alligator mouth wants to eat the big number first. So for example, 2 is less than 4. So we could have an inequality such as x is less than 2, which means find all possible values for x such that x is less than 2. All those possible values are called solutions, and they create a solution set because there are so many of them. And that is why we needed to review a little bit about sets before we started this unit. So if you look on a number line, you can see that 2, say, is about here, and every single number that is less than 2 will satisfy this inequality. So 1, 0, 0.5, -10, etc. All those numbers will be less than 2. However, since there is no equal sign also in the inequality symbol, we are not including 2 at all. Some of the ways of representing these solution sets include showing the solution set on a number line and using interval notation to represent the solution set. Let's first take a look at the number line. So basically, you want to shade the number line wherever the solutions exist. So in our example, x is less than 2, we were shading in, we wanted to make sure 1 was shaded in, -2 was shaded in, 0.5 was shaded in, 1.5, and so on. However, we don't want to shade in 3, 4, 5, and so on. So then we have to indicate an endpoint. Now in our case, since there is no equal sign, the endpoint is not included. So less than or greater than would be an open circle for the number in question. Everything else gets shaded in. Now you could shade it in like this. You could also just draw that and just make it a little more obvious that that whole section is being shaded in. Depends on the thickness of your pencil too. Just make it clear that all of these numbers here are being covered. The textbook, I believe, offers the option to use an open bracket if the endpoint is not included, and they just bold the line. However, if you just bold the line, I may not see which part of the line you have bolded. So if you would like, I almost highly recommend making it a little more obvious, a little more shaded. So let's take a look at if x was greater than or equal to 2. So on our number line, we'd plot our endpoint 2. In our case, the endpoint is included because of the equal sign. So we could use a closed dot. So an endpoint being included is called closed. Endpoint being not included is called open. So this was an open circle. And this is a closed circle. Indicates whether the endpoint is included or not included. Now, for x greater than or equal to 2, we want to shade in all the points that will be bigger than 2 and including 2. And so this diagram represents all the numbers that are greater than or equal to 2. Sometimes we don't want to draw, and we just want to type the answer in or something. So then mathematicians use something called interval notation. So similarly, there's open and closed endpoints. And instead of using open and closed circles, we stick to the open brackets or the square brackets. So let's take a look at the same example. So let's say you were looking at x less than 2. Now, if one of these endpoints is not a particular point, in this case it's not, so on the left hand side you have pretty much negative infinity, because this is going on forever. So if you had to represent x is less than 2 in interval notation, you can kind of imagine it on the number line from left to right. You'd be going from negative infinity, separate with a comma, all the way up to 2. Infinity is always an open bracket, and in this case 2 is not included, so it's also an open bracket. Say you had to represent x is greater than or equal to 2, as in our second example here. So if you look at the number line, you start at 2 from left to right. Always read it from left to right. You start at 2 and you're going all the way up to infinity. Infinity is always open because there's not one single point where it is locked in place. There's always something bigger when you're talking about infinity. And for 2, in this case, there is an equal sign on the inequality, therefore the number 2 is also included in your set, and so square brackets are used for a closed point. So really pay attention to this here. Open circle or bracket, closed, including, shaded in circle, square brackets. Now, if you have something in between two parts, so let's say we wanted to go in between 2 and 3, so all the points between 2 and 3, not including the 2 and not including the 3, interval notation would be all the way from 2 to 3, with 2 being included, square bracket, and 3 being not included. In this unit, we're going to solve some inequalities, and we're going to use the set notation we just learned to represent our answers, but let's just talk about solving inequalities in general. Solving inequalities is just like solving equations, except, now I want you to check this out. Before I tell you what the exception is, just consider when 2 is less than 4, that's a true statement. Now, what if I take a different color and multiply both sides by -1? In an equation, I'd be allowed to do that with no problem. But let's see what happens. -1 times 2 gives us -2, and then 4 times -1 is -4. Now, is this still true? Is -2 less than -4? The sign had to switch. Bam! If you multiply or divide an inequality by a negative number, the inequality sign must be reversed. Let's try some examples. First example, we've got an equation very much like the ones you've solved in the past, although it has an inequality symbol. The only difference is, remember, that if we do end up multiplying both sides by a negative, we will need to switch the sign, but only if you're multiplying by a negative or dividing by a negative. So let's check this out. We've got -3x plus 7 is greater than 11. So just as in equations, we want the x by itself, so let's subtract 7 from both sides. We get negative 3x greater than 4. Now, what we're going to do is we're going to divide by negative 3 on both sides. Attention! What are we doing? We are dividing by a negative. Which means the sign needs to switch. So we have x is less than negative 4/3. Now the negative can be top, bottom, or middle. It doesn't matter as long as it's in one place. So they want us to graph the solution and to give interval notation for the solution set. So to graph the solution, you draw a number line, you plot your point, you decide is it open or closed. There is no equal sign in our inequality, therefore it is open. So it is not including negative 4/3. Open circle, negative 4/3. And now all our numbers that are in our solution set are less than negative 4/3. So everything less than negative 4/3 is shaded in. And that's your graph. To give interval notation, you can read your graph from left to right, so negative infinity all the way up to negative 4/3, and locate the endpoints. The endpoint is not included at negative infinity and also not included at negative 4/3. Let's take a look at the next example. We've got 3/8 x plus 1/2 less than or equal to negative 9. Now, since we have a whole bunch of fractions in this, we want to clear the fractions. So let's multiply everything by the LCM to clear the denominators. You can only do that when you have an equation or an inequality. You can't do that if you didn't have it because it wouldn't make sense. So here our lowest common multiple of 8 and 2 is 8. So let's multiply every single term by 8. Every single term must be multiplied by 8. Now we haven't multiplied by a negative, therefore we keep the inequality symbol as before. Now let's simplify. So 8 and 8 simplifies, so we've got 3x. 2 and 8 simplifies, divide them both by 2, you get 1 and 4. That gives you 4 less than or equal to negative 9 times 8, which is negative 72. Now you have an inequality with no fractions. Woohoo! Alright, let's keep going. So negative 4 from both sides. 3x is less than or equal to negative 76. And we want to divide both sides by 3. And that does not go in equally. So therefore you can leave it as a simplified fraction. So x, and notice I didn't switch the inequality sign because we didn't divide by a negative, only if it's by a negative. So less than or equal to negative, and let's simplify 76/3. So it goes in 25 full times. And there's 1/3 left over. So you could answer it this way. You could also just keep it as negative 76/3 as long as there is no common factor between the numerator and denominator. They want us to graph the solution and give interval notation. So let's take a graph, number line, plot your point. So it doesn't really matter where it is, no scale issues here. But think about what kind of point you want. You want it to be closed because there is an equal sign in the inequality. So we want a full dot at negative 76/3 or at negative 25 1/3. And then you want it to go less than or equal to that. Everything less than or equal to that. And there's your graph. In interval notation, it starts at negative infinity, not including, all the way up to negative 76 thirds, including. Let's continue to some more examples. Sometimes you'll have something that's called a compound inequality, where you have two or more inequalities linked together in one inequality. For example, this statement here. Notice that the inequality signs must be going in the same direction. So this is actually the same as saying x is greater than 2 and x is less than or equal to 5. So if you think about that, on a number line, x's are greater than 2, not including 2, everything bigger, and x's are also less than or equal to 5, closed. And basically what that means is that x is between 2 and 5. Not including the 2, no equal sign, and including the 5 because of the equal sign. In interval notation, that's from left to right, from 2 to 5, not including the 2, open bracket, including the 5, square bracket. So let's try and solve this compound inequality here. The same thing applies as before. We do the same thing to all sides. If, in fact, we end up multiplying or dividing by a negative, we gotta switch all the signs. All right, so let's distribute here first. You could do that, or you could divide everything by -3 right away. But I think some of you are used to distributing first, so let's stick to that. Now we're going to subtract 3 from all parts, giving us -1 less than or equal to -3x less than 1. And now we can divide all parts by -3. Since we're dividing by a negative, that means we need to switch our signs. So they actually switch to go the other way, giving us 1/3 greater than or equal to x greater than -1/3. And when we write these, we always want the alligators eating to the right because we want it to be in numerical order. So we want the smaller number first all the way up to the bigger number. So we actually want to reverse this to say x is greater than -1/3 and x is less than or equal to 1/3 is the same statement. So on a number line, you've got -1/3 and 1/3. And everything in between there is part of the solution. Interval notation is going all the way from -1/3, not including, to 1/3, including.